Hello, everyone. Welcome to the office hour. Hello, Sabin in Nepal. Hello, Oliyemi. Hope you are doing well today. It's another sunny day here in Maryland. Hello, Danielle in Mexico City. I shall have to make it down to Mexico City again sometime. It's been a number of years since I was there. Let's see here. Yesterday we were working on the NLP Mini project. And when we left, I was fitting a model, and I have now fit that model. Well, I adjusted my parameters a little bit between yesterday and today and ran a fit to do a grid search on ridge regression. And I have a model here. Hello, Helena, hello, Igor, and hello, Baron. Baron Sakalioglu. I'm probably mispronouncing that. Anyhow, so the NLP Mini project, right? We had reviews. We had reviews from Amazon. Product review text from Amazon. These are electronics products. We had ratings ranging from 1 to 5 stars. We're trying to predict the rating based on the text from the rating. So NLP, so we are extracting this review text, and we wanted to predict this overall rating right here. So we talked about this, we talked about vectorizing the text. Well, one thing we did was we made a key selector because we have this list of dictionaries. We want to select the text from this list of dictionaries. For each dictionary, we just want this one key value. So we made a transformer, which isn't particularly complicated, but you know, it does the job we want, and that's the whole point. Selects the text. So we have our key selector to get the review text. We'll use the count vectorizer to give us word counts, right? The number of occurrences of each word within each document. Here, a document is a review. We're using the English stop words that are provided by the count vectorizer. And I did a grid search. I upped my rating a little bit. My range on my log space. Yesterday I think I had -1 to 2 with 10 points. Today I ran it with -1 and 3 and 10 points in this range right here, in this log space range, with 5 folds for ridge. Now, all right, I'll have a couple questions for you guys when I'm done talking about what I'm doing here. this probably took about 10 to 12 minutes, I think, on this machine to fit. So not something that you would, want to sit here and observe during the office hour, if we're just sitting here waiting for a model to fit. That's the kind of thing I say, oh, fit my model, I'll wander off, get myself a cup of coffee or something else to drink, and, maybe have a bit of a chat with my wife if she's not busy doing other things, and, or find something to do. When the model finished fitting, I checked the score. Now remember, this score right here is giving us an R squared score. Which is only about 0.4. Of course, I could get predictions from my model. I submitted my predict method to my model, and I got a score on the grader of something larger than 1. Yeah, I looked at my best parameter for the ridge model, and it returned this value here of about 359, right? This is just one of these values right here that was tried. Now, yesterday, we try to fit just using the default value for alpha in ridge, right? The default value is alpha is 1. If I remember correctly, the default value for ridge is 1. Which we could easily check. Ridge. Default value is alpha is 1. If I recall correctly, yesterday, after we did the model fitting with that value of 1 for ridge, the score, the R squared score we were getting was, I think it was something around 0.7 or 0.75. But we were getting a grader score that was negative. Can someone explain why? What was the problem of using a value of 1 for ridge, where I had an R squared score of like 0.7, but my grader score was negative? Why is that? As I said, my R squared score yesterday was higher than the R squared score I'm getting today, but the score on the grader was negative. The grader is more or less comparing the performance of, whatever model you give it to a model that we have previously generated. Our score from the grader was negative. And that basically means we're doing worse than the pre-generated model was doing. It's not really quite a distance, it's I would have to remind myself of the exact scoring method, but the negative score basically means our model that we fit yesterday was doing much worse than the solution that we previously that the model solution, our solution was doing much worse than the model solution on the data that it was given, on the test data. But as I said, our R squared score yesterday was better than the R squared score we're getting today. So let's see if I could summarize here. So yesterday, with alpha equal to, with alpha equal to 1, we had an R squared score of about 0.7, but the grader score was negative. Today, with alpha equal to what? It's about 359. The R squared score is about 0.4, but the grader score is larger than 1. So the model is performing bad in the test data set. Yes. Olea says overfitting question mark, and that's more or less like the answer here. Yesterday we were doing no grid search for this value alpha. Right? We were basically fitting our data to the training data. We were doing no kind of testing to find a good value for alpha. Right? We were overfitting our model to the training data. Remember that one of the key ideas in machine learning is that we want to build a model that will generalize well to data that the model hasn't seen before. That's one of our hopes and one of our goals. We can't always achieve that goal, but we can always have that desire. Right, so yesterday we were like overfitting our data to the training set, because we weren't doing any kind of search, any kind of cross-validation to search for a good value of alpha for this ridge model. So while yesterday we had a higher R squared score, we were overfitting our model, and this is why the grader score was negative. Right? We're doing worse than the model solution was doing on the test set. Today, well, our score is slightly bigger than 1. We're doing better on the test set than the model solution is doing on the test set. Did we put all the data in the 0.7 result? Yes. We trained yesterday, we just fit the model with ridge with alpha equal to 1 to the entire training data set. So, yep, exactly. We put all the data in yesterday. We did no cross-validation. And as Olea says, that's why the grader scored low despite the high R squared. That is precisely why, right? We overfit to the training data. So, today, right, the R squared score is lower. One might argue much lower than the R squared score we had yesterday, but the idea is, well, all right, we're not going to have as good predictions maybe in general, but our model, should generalize to new data. So yeah, once again, we were overfitting to the training data. And that's easy to do, right? If we forget about the need to do cross-validation, to do, this model selection process, to search for these hyperparameters, it can be very easy to overfit to the data, overfit to the training data. Remember, what are we doing when we're using grid search CV? Well, we specified here CV was 5. So we're doing 5 folds. This is dividing the data into 5 parts. And we hold out one part, train on the other 4, and use this part we held out to evaluate. We repeat by holding out each set, building a model, and evaluate using the part we held out. Then we kind of average over these 5 folds, these 5 different models, to get a cross-validation score. And then we change, in this case, the value of alpha and try again. Right? And we basically select the value of alpha, which gives us the best cross-validation score. We could try SGD regressor, but I have another question that I want to ask you guys before we try the stochastic gradient descent regressor. So we use this count vectorizer and we put this into Ridge. Now, if you read the documentation on Ridge, which again we could search RIDGE, right? This is the regularization. If you remember this kind of discussion when we're talking about Ridge and regularization, right? The general idea is for regularization, we want to scale the feature matrix so that our features are on the same, scale to each other. I don't have one feature where the numbers are on the scale 1 to 10, and I have another feature who's on the scale, 10,000 to 100,000. Now, I didn't scale my feature matrix before I used Ridge right here. My question is, why not? Why didn't I scale my features before I used Ridge? Is scaling necessary here? Right. Normally we might say, well, I will do some scaling. I will put in the standard scaler right here, for example. Well, I can't use standard scaler because I have a sparse matrix. I might use the max abs scaler right here to scale my feature matrix. Why didn't I do that this time? Or should I have done that this time? Barron suggests in a bag of words it is like categorical features. Each column is like a word. So they're not like house size, therefore it is not needed, I guess. Yeah, you have the right idea. Like, these are word counts, you know? I'm not going to have like one column being between 1 and 10 and another column being between like 10,000 and 50,000. Well, it's basically because like the word counts are all going to be on a similar scale. As I said, I'm not going to have like one word that will appear in a column like 10,000 times versus that same word appearing, twice in some other documents. Basically, the